Good morning, students. Till now, in gear trains, we had a discussion about the first three types of gear trains, namely simple gear train, compound gear train, reverted gear train. So, after understanding these three types of gear trains, about them, how the arrangement of the gear trains and how the power can be transmitted with the help of the three types of gear trains, and also we have solved simple numericals on it. Now, today, let us discuss about the fourth type of gear train, that is epicyclic gear train. And this is one of the important type of gear train where you may expect the problem which is connected to this. Therefore, I request you people to focus on this epicyclic gear train so that you can solve the problem which will be given. 99% a numerical will be appeared on a epicyclic gear train. Therefore, be focus this video lecture so that you can understand what is epicyclic gear train and what are the methods that are available to find the velocity ratio and which method we are adopting to solve the problems on epicyclic gear train. Now let us begin. What is epicyclic gear train? In an epicyclic gear train, the axis of the shafts over which the gears are mounted may move relative to a fixed axis. Because as we know very clearly that in case of the three types of gear trains which we have discussed already or earlier, the axis of the shaft over which the gears are mounted are fixed relative to each other. In first three types, that is simple gear train, compound gear train and reverted gear train. In these three types which we know already, in these three types of gear trains, the axis of the shafts over which the gears are mounted are fixed relative to each other. But in epicyclic gear train, the axis of the shaft over which the gears are mounted, instead of being fixed, they move relative to a fixed axis. This is what the difference between the epicyclic gear train compared to the earlier three types of gear trains which we have studied. It means, what is the meaning of it? So what I told, in epicyclic gear train, the axis of the shafts over which the gears are mounted may move relative to a fixed axis. What is meant by it? It means that the axis of the gears are not fixed but rotate around the axis of the other gears with which they mesh. This is the point where you must understand, or where it gives the clear-cut meaning for the first point what I told. So what is the first point? In epicyclic gear train, the axis of the shafts over which the gears are mounted may move relative to a fixed axis. Means with respect to the fixed axis, the shafts over which the gears are mounted will move. It means that the axis of the gears are not fixed but rotate around the axis of the other gears with which they mesh. Now, if I look at the diagram, the figure or the diagram shows a simple epicyclic gear train consists of three elements, namely one is arm C, second one is gear A and third one is gear B. So figure indicates or figure shows the simple epicyclic gear train which consists of namely three elements. One is arm C, second one is gear A, and third one is gear B. Now gear A and arm C have a common axis at point O1 about which they can rotate. What is it? Gear A and arm C both are having a common axis at point O1, which can be seen in the figure, about which they can rotate. Similarly, gear B, one more element, meshes with the gear A. So gear B is meshing with gear A, and this gear B has its axis on the arm at point O2, about which the gear B can rotate. So understand, this is the description of the simple epicyclic gear train. So it consists of mainly three elements. One is arm C, second one is gear A, third one is gear B. Now gear A and arm C both are having a common axis at point O1 about which they can rotate. The gear B is meshing with gear A, and the gear B is having its axis on the arm at point O, so that the gear B can rotate about it. If the arm C is fixed, means if the arm C is fixed, suppose if I fix the arm C, that is O1, O2, this is the length of the arm C is fixed, then the gear A and gear B will form a simple gear train, which we have studied the first type of gear train. So if I fix the arm C, then this gear train is behaving like a simple gear train. But if the gear A is fixed, and the arm C is rotated about the axis of the gear A, that is about the point O1, it rotates, then the gear B is forced to rotate upon means epi, and around means cyclic gear A. So what happens? If I fix the arm C, then the gear train is becoming a simple gear train. But if the gear A is fixed, if I fix the gear A and arm C is rotated about the axis of the gear A, then the gear B is forced to rotate upon means epi, and around means cyclic. Such a motion is called as epicyclic motion, and the corresponding gear train is called as a epicyclic gear train. So why this name has been told very clearly, right? Once again I'll repeat, if the arm C is fixed and if arm C is fixed, then gear A will drive the gear B. Thereby this gear train is simply behaving like a simple gear train. But if the gear A is fixed and arm C is rotated about the axis of the gear A, that is about the point O1, then the gear B is forced to rotate upon and around the gear A. The gear B is rotates upon and around the gear A. So then upon means epi, around means cyclic. Therefore, such type of motion is called as epicyclic motion. So when this gear train is said to be epicyclic gear train, whenever the gear A is fixed, when the gear A is fixed and arm C is rotated about the point O or about the axis of the gear A, then gear B will automatically rotates upon and around the gear A. Such a motion is called as epicyclic motion, and then the gear train is said to be a epicyclic gear train. And in the figure, if you look at, as I said, there are three elements in which there are two gears other than the arm C, which is a link, so connecting the two gears. The main gear in the train, that is gear A, is called sun wheel, and the gear at the end of the arm is called as a planet. So in the figure, if you look at, main gear is gear A. So gear A is said to be sun wheel, and the gear B, which is at the other end of the arm, is said to be a planet wheel. If the gear train consists of internal gears, so here the two gears, gear A and gear B, both are having an external gears. Suppose if the gear train is having gears internally, then such kind of wheels or gears are said to be annulars. So this is the terminology of a epicyclic gear train. So now only here I am just talking about a simple epicyclic gear train, and we can also see in a epicyclic gear train, maybe it is a simple epicyclic gear train or there may be a compound epicyclic gear train. Now in a simple epicyclic gear train, main gear, that is gear A, is known as sun wheel, and the gear B is known as a planet wheel. If the gear train consists of internal gears, such kind of gears are called as annulars. Now if I look at it, so this is all about the description, how it works, when it behaves like a simple gear train, when this gear train is said to be epicyclic gear train. So after understanding this, now what are the application? So these epicyclic gear trains are useful for transmitting high velocity ratio. So whenever you need to transmit a high velocity ratio, so in such situations we will prefer among the different types of gear trains epicyclic gear trains. So therefore, especially epicyclic gear trains are useful for transmitting high velocity ratio with gears of moderate size, means medium size, in a comparatively lesser space. So these are the 3 points based on which this type of gear train will be preferred. One is whenever we need to transmit the high velocity ratio, and whenever we have a gears of moderate size, and whenever we have a lesser space. All these 3 things make us to prefer a epicyclic gear train. Now epicyclic gear train are used, one can see the epicyclic gear train in case of the back gear of a lathe and the differential gears of an automobile, hoists, pulley blocks and wristwatches. So these are a certain specific applications one can observe or one can see the mechanism, that is epicyclic gear train. Now as we all know that our main motto or main objective in case of any type of gear train is to find the velocity ratio or speed ratio. Now, how to find the velocity ratio in case of a epicyclic gear train? So, normally there are 2 methods with which one can find the velocity ratio in case of epicyclic gear train. One is tabular method, the other one is algebraic method. But I will explain first of all both the methods, how the velocity ratio of a epicyclic gear train can be found by using tabular method and as well as algebraic method. But one point you must remember, so more oftenly the easiest method to find the velocity ratio in case of epicyclic gear train is a tabular method. Therefore, so first I will explain how to find in general the velocity ratio by using tabular method and as well as algebraic method. But once I start solving the problems on epicyclic gear train, we will follow a tabular method. Now let us go for first method of finding a velocity ratio in case of what type of gear train? Epicyclic gear train. First, it is a tabular method. Now, as you know, epicyclic gear train, it consists of mainly two gears, gear A and gear B. Look at the figure. Consider an epicyclic gear train which is already explained with the help of diagram. With respect to that, let us take TA and TB, or number of T's on gears A and B. Here the gear A and gear B are having the certain number of T's. So therefore, let us take TA and TB, or the number of T's on gears A and B. Similarly, so NA and NB are the speed of gears A and B in so many revolutions per minute. So after assuming this, or after considering this, because other than the arm C, in a simple epicyclic gear train, there are two gears having certain number of T's and they rotate with a certain speed. Therefore, let us take TA and TB, or the number of teeth on gears A and B. NA and NB are the speed of the gears A and B in so many revolutions per minute. Initially, how to start? So initially, let us assume that in a epicyclic gear train, we know we have only three elements. Please remember, we have three elements. What are they? Arm C, gear A and gear B. So initially, let us fix the arm C. So initially, let us assume the arm C is fixed. Hence, the axes of both gears are also fixed relative to each other. So by fixing the arm C, so initially what is the step? We have to assume certain thing. Among the three elements, one of the element to be fixed, preferably arm. So here there is one arm, that is arm C. So let us assume the arm C is fixed. By fixing the arm C, what I do, or let us give one revolution for the gear A in an anti-clockwise rotation. Please understand, I am repeating once again. Initially, in a tabular method, among all the elements which are there in a given epicyclic gear train, one of the element is to be fixed, preferably arm. So here, arm C. So let us assume arm C is fixed. After fixing it, what I should do? I should give one of the gear, that is, I am giving a gear A one revolution in anti-clockwise direction. So by fixing the arm C, give one rotation in anti-clockwise direction for the gear A. Then what happens? The gear B will rotate in clockwise direction, because arm is fixed. When the arm is fixed and the gear A is rotated in the opposite direction, the gear B will rotate. That is why I told in the beginning. So when the arm is fixed, the gear train is behaving like a simple gear train. Therefore, in tabular method, to find the velocity ratio, initially we have to assume that one of the element is to be fixed. So now in this simple epicyclic gear train, arm C is fixed. I am going to fix the arm C and I am going to rotate the gear A one revolution in anti-clockwise direction. Then the gear B will rotate in clockwise direction. Now let us assume the anti-clockwise as positive and clockwise rotation as negative, let us find the velocity ratio between the gears A and B. Because what I am doing, by fixing the arm C, I am rotating the gear A. As a result, gear B is rotating in opposite direction. Now the gear A and B are directly or in mesh with each other, and they are rotating in opposite direction. So obviously one can find the velocity ratio between the gears A and B. So what is the velocity ratio? Ratio of speed of the driver to the speed of the driven, that is NA by NB, is equal to ratio of reciprocal of their T's, that is TB by TA. Now, or I can write NB by NA is equal to TA by TB, vice versa. Now, substitute the values. NB, that is speed of the gear B, that I don't know. And NA means what? Speed of the gear A. What I am doing, what I did for the gear A, I rotated gear A by 1 revolution. So, therefore, 1. And plus 1 I substituted because anti-clockwise direction I rotated gear A 1 revolution. Therefore, NB by NA is plus 1 because gear A is rotated in anti-clockwise. So, therefore, plus how many revolutions? 1 revolution. Plus 1 is equal to TA by TB, which in turn cross multiply NB is equal to TA by TB clockwise, because NB is what? Speed of the gear B. When gear A is rotating in anti-clockwise, gear B will rotate in clockwise. Therefore, speed of the gear B, that is NB, is equal to TA by TB, and that I wrote it as minus because gear B speed is TA by TB, but it is rotating in clockwise, therefore minus TA by TB. So this information is to be entered into the first row of the table. This is what the table which we have to prepare. So there are, first column is step number 1, 2, 3, 4. Second column, conditions of motion. So what is the conditions of the motion? And third one, revolution of elements. So here how many elements? Arm C, gear A, gear B. Like that, in that column bifurcation. Once again, sub columns, arm C. Suppose if I have gear C, one more. Like that, mainly 3 columns. Step number, conditions of motion, and third one, revolutions of motion. In the revolutions of elements, I may be 3 columns or 4 columns, 5 columns. That depends upon how many number of elements in the given epicyclic gear train. In the epicyclic gear train, whatever I took an example, in that 3 elements, what are they? Arm C, gear A, gear B. I wrote it in that order. Like that, you have to prepare a table, and whatever I told earlier. First, how to begin the tabular method? One of the element is to be fixed. Here the arm C is fixed. Then after fixing the arm C, what I should do? I should rotate one of the gear. Here I rotated the gear A 1 revolution in anti-clockwise. Thereby the gear B, another gear B, which is in mesh with gear A, rotates in clockwise. Assuming anti-clockwise as positive and clockwise as a negative, I found what is the speed of the gear B. That is equal to TA by TB, and it is minus because it is clockwise. This information is to be entered in the first row. First step is step 1. Arm fixed. That is what I did. Arm is fixed. Gear A rotates plus 1 revolution, because by fixing the arm C, I rotated the gear A 1 revolution. Right. So I should write what is the condition. So arm C is fixed. Gear A is rotated plus 1 revolution. Plus 1, why I wrote it plus 1? Because the gear A rotated in anti-clockwise. 1 revolution. Therefore plus 1. And next, in the revolutions of the elements, there are three sub-columns. One is arm C, gear A and gear B. Now arm C is fixed. Therefore revolution, arm C is fixed. Therefore what is the speed of arm C? 0. And gear A, it is rotated by one revolution in anti-clockwise, therefore +1. Arm fixed, therefore in the arm C I should write 0. Gear A rotated +1, so +1 I should enter. And for gear B, that is nothing but speed of the gear B, that is minus TA by TB, which I found. Like that, this information is to be entered very clearly without any confusion. Then further 3 steps are very easy, right? Once again I'll repeat. In tabular method, initially one of the elements in a given epicyclic gear train is to be fixed. Now in our example, there are 3 elements, arm C, gear A, gear B. Among these 3, preferably you have to fix arm C. Therefore arm C is fixed, and after fixing the arm C, one of the gear is to be rotated. I rotated gear A by 1 revolution in anti-clockwise direction. Then what happens? The other gear, that is gear B, which is in mesh with gear A, will rotate in opposite direction, means in clockwise direction. Assuming anti-clockwise as positive, clockwise as a negative, let us find what is the speed of the gear B. Because arm C is fixed, the speed of arm is 0, and the gear A have rotated by +1 revolution, so speed is +1 RPM of gear A. And I should find gear B because it starts rotating, because it is in contact with gear A and it starts rotating in anti-clockwise. Therefore I should find the speed of the gear B, that is NB, which I found as minus TA by TB. So minus indicates a clockwise. Gear B is rotating clockwise and its speed is TA by TB. Therefore, after drawing a table like this, first column is step, second column is conditions of motion, third column is revolution of elements. In the revolution of elements, again there will be sub-columns. That depending upon, here there are 3 sub-columns because there are 3 elements, arm C, gear A, gear B. Like that, any number, how many elements are there in a epicyclic gear train, that many number of sub-columns under this revolution of elements. After preparing, first step, write it as 1 and write down the condition. What is it? Arm C is fixed and gear A rotates +1 revolution. 1 revolution, 1 RPM, but in anti-clockwise, therefore +1 revolution. Arm C is fixed, gear A rotated +1 revolution. Then you enter the information. Arm C, inside this cell, I should put 0 because arm is fixed. Gear A, what is the speed of gear A? 1 revolution anti-clockwise, therefore +1. And what is the speed of gear B? Just now I found using a velocity ratio minus TA by TB. Minus TA by TB. Like that you have to enter very clearly. Next, step 2. What I should do now? I should multiply all the speeds with x. Simply x. Multiply by x. Same condition. Arm is fixed. Now instead of gear A, which has been rotated by +1 revolution, now gear A should rotated by +x revolution. Don't get confused. Simply you multiply by x, means I should multiply 0 with x, means I will get 0. +1 with x, +1 into x, that is +x. X into minus TA by TB. So minus x into TA by TB. Like that, second row is to be completed. In the second row, what I should do? Simply, I should multiply all the speeds with plus x. That is 0 into plus x. 0 into x, that is 0. 1 into x, that is x. Plus 1 into plus x, that is plus x. And plus x into minus Ta by Tb, that is equal to minus x into Ta by Tb. Like that, second row is simply multiplying all the values with y. Then third step, add plus y revolutions to all elements. Plus y means what I should do? Previous row is 0. 0 plus y is plus y. Plus x plus y. If I add, so just I should add plus y revolutions to all elements. So just simply plus y plus y plus y. You write it simply plus y plus y plus y, because I should add plus y revolutions to all the elements. Plus y plus y plus y. Now find out in the fourth step the total motion. So total motion of all the elements. How to get the total motion? You have to add second row and third row. Means 0 plus y is plus y, plus x plus y is x plus y, and minus x into Ta by Tb plus y, that is nothing but y minus x into Ta by Tb. So like that, this completes the table. First, after the table is drawn, first step is what? Arm is fixed and the gear A is rotated plus 1 revolution. Hence, the speed of the arm C is fixed and the speed of the gear A is plus 1 and the speed of the gear B is minus Ta by Tb, because it is clockwise. After this row, remaining 3 rows or remaining 3 steps are blindly you can fill. What is the second step? You have to multiply by x. 0 into x is 0. 1 into x is x. Minus Ta by Tb into x, that is minus x into Ta by Tb. What I did? Simply I multiplied the previous row with x. 0 into x is 0. Plus 1 into x is plus x. X into minus Ta by Tb is minus x into Ta by Tb. Next, go to the third row. In the third row, simply put plus y plus y plus y for all the elements. So that is what I did. Add plus y revolutions to all the elements. Plus y plus y plus y. Then find out in the last step total motion by adding the values of second and third row of the elements. Here arm C second row is 0. Third row is plus y. So if I add 0 plus y, it will be plus y, and gear A plus x plus y, that is be x plus y, because both are positive, and gear B second is minus x into Ta by Tb, this is y. If I add these two, then it will be y minus x into Ta by Tb. So don't forget to plus and minus carefully. Here simply 0 plus y, I can put simply y. But here, as I should follow the sign conventions, though if y means by default I know plus y, but you people will confuse. Therefore, wherever you get plus minus, even though it is not required, try to put it as, instead of y, you write it as plus y. Here x plus y, y minus y. Like that, table should be very clear. After preparing the table, right, after preparing the table, finally, if the rotation of any 2 elements are known, so among the 3 elements in the epicyclic gear train, so if the rotation or if the speed of any 2 elements are known, then the unknown speed of the third element can be found by substituting the given values in the last column of the fourth row in the table. So this is the way, the tabular method. First you must be thorough with how to prepare a table and what are the things to be remembered while preparing a table. After that, how to find, what is to be find, how to find and all that we will discuss it once we go to the problems. Next, second method is, as I said, algebraic method. In algebraic method, the motion of each element of the epicyclic gear train relative to the arm is set down in the form of equations. See, in tabular method, we have prepared a table. So in algebraic method, the motion of each and every element with respect to a fixed one will be framed in the form of equations because it is an algebraic method. Algebraic means it contains a certain equation. Therefore, the number of equations, how many number of equations I am going to get? So the number of equations depending upon the number of elements in a gear train. So because here arm C is fixed, so the three elements are there. So three equations are possible. If the arm C is fixed, because just now I explained in case of tabular method, preferably which element is to be fixed? Arm C is to be fixed. Then once the arm C is fixed, then the speed of the gear A relative to the arm C will be equal to NA minus NC. So if the arm C is fixed and gear A is rotated, then the speed of the gear A with respect to the arm C will be equal to the relative speed, that is NA minus NC. I am finding the speed of gear A with respect to C, therefore A minus C. Then the speed of the gear B relative to the arm C will be NB minus NC. Like that, fix the arm C and find out the speed of gear A and the speed of gear B with respect to the arm C which is fixed. That is, speed of gear A is NA minus NC, speed of the gear B is NB minus NC. Since the gears A and B are meshing directly, they revolve in opposite direction. That is what I explained already. If the gear is rotated in anti-clockwise, gear B is rotating in clockwise. So both are rotating in opposite direction. Therefore, now as they are directly meshed with each other and both are rotating in opposite direction, one can find the velocity ratio between the gears A and B. How to find the velocity ratio between the gears A and B? That is speed of the gear B by speed of the gear A, that is equal to NB minus NC by NA minus NC. Speed of gear B is what? Just now I calculated, it is NB minus NC. Speed of gear A is NA minus NC. That is equal to TA by TB, because here B by A reverse A by B. Suppose if I can write velocity ratio is also equal to, I can write speed of gear A by speed of gear B. Then it will be TB by TA. So vice versa. So now I wrote velocity ratio is equal to speed of gear B, that is NB minus NC, by speed of gear A, that is NA minus NC, which is equal to reciprocal of the ratio of reciprocal of their T's, that is TA by TB, and that is equal to minus because the gear B is rotating in opposite direction or in clockwise direction. Now arm C is fixed, therefore speed of the arm C, that is NC, is equal to 0. Now if I substitute NC is equal to 0, then it will be in the above formula, then NB by NA is equal to minus TA by TB. And instead of arm C, if the gear A is fixed, then NA will be 0, because gear A if I fix, then if I substitute NA value which is 0 after fixing in the velocity ratio equation, NB minus NC as it is divided by NA, now it is 0 minus NC, that is equal to TA minus TA by TB, which in turn NB minus NC and 0 minus NC is minus NC, that is equal to minus TA by TB. Now NB minus NC is equal to, if I cross multiply, minus NC into minus TA by TB will be NC into TA by TB, because both are after cross multiply minus into minus plus. So NC into TA. Just I cross multiplied. Then I found NB. So to find NB, I should bring this NC, which is on left hand side, to the right hand side. Then it will be NB is equal to NC, which I brought onto the right hand side, plus already there is NC into TA by TB on the right hand side. So now NB is equal to, here NC is common, taking outside, then here I left with 1 and here I left with TA by TB. So NC into 1 plus TA by TB. Now once again NB by NC, so is equal to 1 plus TA by TB. Like that you can find the speed of the gear B with respect to the gear C by algebraic method like this. So this is only a description of an tabular method and algebraic method with which one can find the velocity ratio in case of a epicycle gear train. Now look at all of you. So as it is an important, and you will get definitely one problem on epicycle gear train, right? So, and you have to be thorough with only one method. What is that method? Tabular method, because it is the easiest method to find the velocity ratio in case of given any type of epicycle gear train. Therefore, just for understanding purpose, I explained both the methods, but you please remember we have to follow a tabular method, especially with respect to the epicycle gear train problems, as it is a easiest method. Right? So students, just remember only tabular method, whatever I told. Now we can solve one problem today on epicycle gear train. I will read out the statement. In an epicycle gear train, an arm carries two gears A and B having 36 and 45 teeth respectively. If the arm rotates at 100 rpm in the anti-clockwise direction, about the center of gear A, which is fixed, determine the speed of gear B. Next, if the gear A, instead of being fixed, makes 300 rpm in the clockwise direction, what will be the speed of gear B? Here there are two parts. The figure, it is an epicycle gear train. Moreover, it is a simple epicycle gear train. And there is an arm C which carries two gears A and B that you can see in the figure. Both gears are having teeth 36 and 45. So first let us write down, list out what are the given things. So arm C is carrying two gears A and B having 36 and 45 teeth respectively. Therefore, number of teeth on the gear A is 36. Therefore, TA is equal to 36, and the number of teeth on the gear B is 45, that is TB is equal to 45. That is what the first sentence. Next, if the arm rotates at 150 rpm in the anti-clockwise direction. So now arm means C, arm C. So arm C is rotating. If the arm rotates at 150 rpm in the anti-clockwise direction, means NC is equal to 150 rpm, it is plus because it is anti-clockwise. Next, about the center of the gear A, which is fixed, determine the speed of the gear B. So first part, that is A, is equal to NB is equal to what? If NA is equal to 0, because gear A is fixed. So if gear A is fixed, then what is the speed of the gear B? I will repeat once again the second sentence of this statement. If the arm rotates at 150 rpm in the anti-clockwise direction, about the center of gear A, which is fixed, determine the speed of gear B. Therefore, the speed of the gear B, that is NB, is equal to what? If the gear A is fixed, means speed of the gear A will be 0. Next, if the gear A, instead of being fixed, if it makes 300 rpm in clockwise direction, then what will be the speed of the gear B? So NB is equal to what? Once again, if the speed of the gear A is equal to 300 rpm, in the bracket write down clockwise, because clockwise is negative, anti-clockwise is positive. So wherever you find the speed, you please write it in the bracket as clockwise and anti-clockwise. So understand here, first sentence, in an epicyclic gear train, arm carrying two gears whose teeths are given. Gear A is 36, gear B is having 45. Therefore, TA is equal to 36, TB is equal to 45. And what he is saying, if the arm rotates at 150 rpm in the anti-clockwise direction, so speed of the arm C, that is NC, is equal to 150 rpm in the bracket anti-clockwise. And this arm C is rotating about the center of which gear? Gear A, and which is fixed. Therefore, gear A is fixed. Then determine the speed of the gear B. So first part of the problem is speed of the gear B, that is NB, is equal to what? If the gear A is fixed, nothing but if the speed of the gear A is equal to 0. Similarly, instead of the gear A which is fixed, if the gear A makes 300 rpm in the clockwise direction, then what is the speed of the gear B? That is the second part. So NB is equal to what? If the speed of the gear A, that is NA, is equal to 300 rpm in the bracket clockwise. Like that, remember the sign conventions. In some textbooks, they may take clockwise as positive, anti-clockwise as negative. But I will solve, right, all the problems by assuming only, and you people also stick on to the same sign convention so that there will be no confusion. Note down the problem and try yourself assuming anti-clockwise as positive and negative, clockwise as negative. So finally, see, answer will be same, maybe plus or minus. Only sign conventions may be different, but value will be same for both of us, even though the sign conventions are interchanged. So remember, according to me, anti-clockwise is positive and clockwise is negative. Now, as I said very clearly that I am going to follow only a tabular method. So in the tabular method, first count how many elements are there? 3 elements. Arm C, gear A and gear B. So now you draw the table. First column is step, second one conditions of motion, and third column revolutions of elements. Elements, how many elements? There are 3. Therefore, I have drawn the 3 sub-columns. One is arm C, second one is gear A, and the third one is gear B. First step is what? Always one of the element is to be fixed among 3. Here, preferably arm C. So, arm C is fixed and gear A is rotated plus 1 revolution. Means I am rotating the gear A by 1 revolution. In what direction? Anti-clockwise. Therefore, I wrote it plus 1 revolution. Next, arm C is fixed. Therefore, in arm C, you write down 0. Means the speed of the arm C is 0 because it is fixed. And gear A is rotated plus 1. Therefore, add plus 1 in gear A. So, plus 1. So, then gear B, speed of the gear B will be TA by TB. So, look at here. I am just giving one blind tip to find directly the speed of the gear B. Because arm C anyhow it is fixed, so speed is 0. Gear A, you only rotating 1 revolution in anti-clockwise, therefore plus 1. But how to find the gear B?
So when I need to enter the speed of the gear B in this cell, gear B speed I want. Therefore, gear B is a driver, gear A is a driven. So then what is the velocity ratio? NB by NA is equal to ratio of reciprocal of their T's. Here BA, previous one will be in the numerator and denominator will be the present one. So TA by TB. Here I am finding the speed of the gear B with respect to A. Therefore, that is equal to TA by TB, previous divided by current. So TA by TB, and gear B rotates in clockwise, therefore negative. Blindly you can write it instead of what I explained earlier, because as the number of elements are increasing, so it will be time consuming, even though the tabular method is easiest. So one should remember, right? RMC NO fixed, you are going to straight away put 0. Gear A NO you are rotating by one revolution in anti-clockwise, therefore no confusion in writing +1 in gear A. And what about the gear B? Gear B. So speed of the gear B should be written in the form of the T's. So gear B speed means, right, so reciprocal, ratio of reciprocal of their T's, that is previous divided by present. So previous is A, current is B. So therefore TA by TB, that gives the speed of the gear B, and it is in clockwise, therefore minus. As I take up problems, you will come to understand how to complete it very easily without any confusion and quickly. Now step number 2. Again RMC is fixed. Now the gear A, instead of rotating +1 revolution, rotate it by +x revolution. Nothing but what I should do in the second step, multiply all the elements with the +x. Multiply all the elements with +x, means 0 into +x is equal to 0. +x into +x, sorry, +1 into +x, that is +x. So x into minus TA by TB, so minus x into TA. So what I did in the second step, I multiplied each and everything. I multiplied the first row values with x, plus x. 0 into x is 0, +1 into x is plus x, minus TA by TB into x is minus x into TA by TB. I multiplied previous row values with x. Next, in the third step, add +y revolutions to all the elements. So simply in all the three, for all the three elements, you please write it +y, +y, +y. Then find out the total motion, that is step number 4. In the total motion, what I should do, I should add 2 and 3 under each column. For the RMC, this is the second step and this is the third step. Second and third step should be added. 0 plus y is y, plus x plus y is x plus y, minus x into TA by TB plus y. If I add these two, then it will be y minus x into TA by TB. Like that. First give +1 revolutions, enter the values, then multiply x with all the values, then add +y to all the elements, then finally calculate the total motion. So total motion of the RMC, for that add step 2 and 3, 0 plus y, that gives plus y. X plus y, that is x plus y, minus x into TA by TB plus y, that will be y minus x into TA by TB. Like that you have to prepare the table and now come to the findings. So what are the two findings here? First finding, NB is equal to what? That is speed of the gear B is equal to what? If the gear A is fixed, that is if NA is equal to 0. That you write it. Speed of the gear B if the gear A is fixed. So now what is the given thing? Speed of the arm, that is NC is equal to 150. Speed of the arm C is equal to 150 RPM anti-clockwise. Now from the fourth row, third column, fourth row, third column, because totally there are 1, 2, 3, 4, 5 columns. And how many rows? 4 rows. 1, 2, 3, 4, which are named as 4 rows and 5 columns. Now from the table, in the table, fourth row, third column, that is arm C. What is its speed? Plus Y. Therefore, speed of the arm is nothing but plus Y, that is equal to 150 RPM, and it is anti-clockwise, therefore I wrote it as plus. So Y is equal to plus 150 RPM. How I got it? After preparing the table. After completing the table, plus Y is nothing but speed of the arm C. X plus Y is nothing but the speed of the gear B. And Y minus X into TA by TB is the speed of the gear B. Like that one should remember and understand after completing the table. Again I am repeating. After completing the table, in the last row, arm C speed is plus Y. Plus Y is the speed of the arm C. X plus Y is the speed of gear A. Y minus X into TA by TB is the speed of the gear B. Like that one should remember and keep it in mind. Now find out the speed of the gear B if the gear A is fixed. So speed of the arm is given, that is 150 RPM anti-clockwise. But from the table, what is the speed of the arm C? Y. That is equal to 150 RPM, and I wrote it here this as plus because it is anti-clockwise. That is first thing. Second, I should find the speed of the gear B if gear A is fixed. Therefore, gear A is fixed means the speed of the gear A is 0. But what is the speed of the gear A from the table? It is X plus Y. Therefore, X plus Y is equal to 0. How I got it? X plus Y is equal to 0? He is asking gear A is fixed. Then what is the speed of gear B? So, speed gear A is fixed means NA is equal to 0. But from the table, what is the speed of gear A? That can be seen in the last row, X plus Y. Therefore, X plus Y is equal to 0. X plus Y is the speed of the gear A from the table, that is equal to 0. Now I know already Y is equal to plus 150 RPM. Substitute Y value in this equation. Then X plus 150 is equal to 0. Then X is equal to minus 150 RPM. Now what I should find? Speed of the gear B. Now go to the table and borrow what is the speed of the gear B. That is equal to Y minus X into TA by TB. That is why I told after completing the table, from the last row, one can identify speed of the arm C is plus Y, speed of the gear A is X plus Y, speed of the gear B is Y minus X into TA by TB. Now, speed of the gear B which I should find from the table, speed of the gear B, that is NB is equal to, from the table, Y minus X into TA by TB. Y just now it is plus 150 minus X. X is minus 150, therefore minus of minus 150 into TA is a number of T's on the gear A, that is 36. TB, it is the number of T's on the gear B, that is 45. So everything if I substitute, if I simplify, I'll get plus 270 rpm. I'm going to get 270 rpm. It is plus. So therefore, speed of gear B, that is NB, is equal to 270 rpm, and here if nothing is there means plus, therefore in the bracket you must write anti-clockwise. This is the speed, means speed of the gear B will be equal to 270 rpm if I fix the gear A and rotate the arm at a speed of 150 rpm in the anti-clockwise direction. Similarly, the second part of the problem is speed of the gear B, that is once again NB is equal to what? If the gear A makes 300 rpm clockwise. As the gear A makes 300 rpm clockwise, hence from the table, what is the speed of gear A? X plus Y. Look at the last row in the table. So X plus Y is the speed of the gear A, that is equal to 300 rpm, that I wrote it as minus because it is clockwise. So X plus Y is equal to minus 300. Y, it is already known, it is plus 150. Therefore, X plus 150 is equal to minus 300, and if I take it plus 150 to the right hand side or on the other side, it will be minus 150. Thereby, X is equal to minus 450 rpm. Y is equal to 150, that is common, but now instead of gear A, which is fixed, gear A is making 300, then X value will be minus 450. Now I know Y is equal to plus 150, X is equal to minus 450. Once again, speed of the gear B, that is from the last row, NB is equal to, from the table, NB is equal to Y minus X into TA by TB. Y is plus 150 is substituted, minus X is minus 450. Minus it is already there, and X value is minus 450 into 36 by 45, which comes 510 rpm. That is 510 rpm means it is plus. Nothing is there means it is plus only. So now the speed of the gear B, that is NB, is equal to 510 rpm. Because it is plus, therefore in the bracket I will write down anti-clockwise. Like that, the speed of the gear B can be calculated if so. This is one problem. So as I am going to solve more number of problems, then you will understand how quickly the table can be prepared and how quickly the things can be calculated, whatever it is being asked in the problem. Now it is only a simple. So once again, tomorrow I will recall, in the next class I will recall how to prepare a table and how to find the things. After that, I will solve more number of exercises because I said very clearly that. So definitely one problem will be given, even not only in the IA, even in the end examination also you are going to get one full question on gear train, especially the problem on epicyclic gear train. So I will give more focus so that you will be thorough with a tabular method. Thank you. Today